Hello. As you can see, I work a lot with technology. So good afternoon, everybody. My name is Mark Standeaven. I'm here to share with you a case study that I happen to be responsible for with a company called Capgemini. And it's a case study about quality, and in particular, implementing a structural quality program to improve the way that we've built software for clients, but also the management of software that clients have built themselves, and hopefully on the way share some best practices and examples that you can use in your own organizations. And as you'll see, the story is actually quite a lot about cows and cowboys. So hopefully that will mean a lot more to you in a few minutes. Now, am I using the right one? First question. There we go. So as case studies go, let's talk just very briefly about the company, and I won't bore you with this. The most important thing on this slide is to know that Capgemini is an IT projects company. We're not a management consulting. We're not a bunch of accountants. Our bread and butter, where we make our money, is in writing software and managing software. Over 80% of the money that we generate every year is through projects in one way or another. And the other thing to bear in mind is that we work across all sectors. We don't just focus in public or private or healthcare. We are spread across all sectors. And it's a very important point to make in terms of quality assurance, that it's obviously not sector specific, and the best practices you'll see in a moment can be applied to any of those. What's more interesting, perhaps, is this. And it shows the changing nature, I think, of the IT industry over the last 10 years. And you know, we're the same as an Accenture or an IBM in this respect. Today, we've got about 130, little over 130,000 employees. But the important thing to note is nearly half of those are working offshore. Okay? In Russia, I'm not sure how big the offshore market is today, over the next couple of years, but it will come. For us, it came in about 2004. Okay? That's when strategically we decided to establish a center in India. And today, and this comes as a bit of a surprise for a French-owned company, I can tell you, we've got about 50,000 people in India today working for us, and it's over double the size of the workforce in France. And it's not always a moment of celebration in France to know that. Another figure I'll share with you is, in terms of Russia, and I apologize, but I can tell you that we have 3 times as many employees in Russia today as we do in the whole of Middle East and Africa. Unfortunately, as we only have 43 people in Middle East and Africa, it's not a great reason for celebration. But hopefully that will change one day. This distributed nature of our workforce simply reflects the growing trend that more and more work goes offshore today. And it's one of the reasons that drove us to this program of quality assurance, in fact. If you take a project in North America or the UK, particularly still Anglo-Saxon countries, offshore working is still developing in many European countries, but in the Anglo-Saxon world, it's been there for many years. So a project manager in North America, 60, 70, 80% of his team will be in India. Sometimes he may not even know the members of his team, because rates of attrition and the changing workforce in India is usually pretty rapid. So it's no longer possible for that project manager to do peer-level reviews himself or actually see what some of the output is that that team is producing. So he needs to implement a way of quality assuring output which is different to some of those older techniques where offshoring is not so prevalent. There's another reason, though, why this is important, and it's a strong economical reason. A company called ISG that some of you may know, which is an analyst company, often advising clients on how to get the best money out of their third parties in negotiation. Did a study a couple of years ago, but it still is relevant today. We showed why do customers choose to use a third party? What are they looking for from that third party when they look after their applications in applications management? And it wasn't cost. It wasn't price as the #1 reason. It was actually to improve the quality of their applications. Okay, so no longer is it just a cost-cutting exercise to outsource an application. It's all about how do I improve the quality of my customers' applications. And why? Well, the OMG recently did a study, and I saw Richard Soley before. I don't know if he's still here, but he can testify to this one. When you look at the typical build lifecycle of an application, sure, 92% of the effort you spend in that build lifecycle can be in finding functional bugs about what you've actually written. But that only contributes about 10% of the issues you're going to find in production. And that production runs for years. So all that time and effort in testing and quality assurance in build actually only helps fix about 10% of what you're going to find in production, those functional errors. Whereas bad coding practices at the system level, or let's call it structural quality, we're talking about the underlying architecture, the design of the application from a performance, security, traceability point of view. That, during the build lifecycle, is only spending about 8% of our time, and yet generates 90% of the serious issues we find in production. So all that effort we spend in managing an application, most of it could be reduced if we just dedicated a bit more time to managing and improving the software quality assurance at the structural level of the software we're actually building. And there's a little benefit that we've seen ourselves, that if you can actually improve that structural quality through testing during the build, you reduce the rework you're doing while you're actually building the application. So there is a strong economic reason for both customers and big IT companies like ourselves to focus on this. And then we come to the cows, or in rather just a minute. In days of old and even agile practices today, there is strong emphasis on peer-level reviews and, let's say, a second pair of eyes on the code. That's a bit tricky, though, when we're looking at structural quality of software. And from our own experiences, we felt that the best way to implement this kind of structural code testing was not to have the project team do it itself, but to have an independent organization do it. And independent testing today in the marketplace is huge. More and more you will find that the testing of the software is being removed from the project team itself, but handed over to factories or third parties to do. We followed that trend. And the way, or the best analogy you can think of this is a blood test, and it follows a little bit on from our previous presentation. We think of structural testing a bit like having your blood tested, okay? In other words, when you have your blood tested, you will go to a laboratory, they will take a file of your blood, they will send it away from analysis, and then they will send that to a doctor, and they will interpret those results either through a computer or through a human and tell you whether you're healthy or not. And if you're not healthy, how should you become healthy? We feel with software it's exactly the same. We ask the project manager to do a blood test on his software once every 3 months, or once every 6 months, depending on the kind of project. He packages up his blood or his software code, and he sends it away to a laboratory, which is in either Morocco or in India. And that laboratory then analyzes that software in the same way that your blood would be analyzed against a series of rules and best practices, and sends you back a report. Actually sending a report to a doctor as well, who is an expert in that technology. And that expert then gives you a call as a project manager and gives you a diagnosis of your code. And we've set up these laboratories around particularly the offshore locations. And by doing that, we're actually, and I'll come to some figures a bit later, seeing some interesting trends in how the health of software is improving over the last couple of years, in most areas, though there is one which still remains a problem in the industry. But a side effect of that is around this question of estimation and productivity. The previous slide, we talked about the fact that in production, 90% of the effort we're spending is through structural problems. It makes perfect sense then, if we understand how structurally competent or strong our application is, we can estimate how many people we need to manage that application in production. In other words, let's focus on what we call the cows instead of the cowboys. The cows are the applications. The cowboys are just those guys who manage them. This is a complete difference to how estimation in applications management was done before, and still continues to some extent in the industry, where as an IT provider, one will go to a client and say, how many people or how many cowboys have you got managing your application today? And the IT provider would come along and say, okay, well, next year we'll do 5% less cowboys, 10% after that, 20% after that. It's completely irrelevant when you look at structural quality, because what you can say is, well, how healthy are cows? Are they big cows? Are they small cows? Do they need a lot of food? Do they not need a lot of food? And the software itself suddenly becomes the reason how you estimate how many people you need to manage it. And that's where we're going now, and that's where we are now. Very, very thick slide, just to tell you that to do automated code quality checking, you can build your own tools if you like, and there are open source tools out there such as Sonar that will do it for you. But we decided to go with a product called Cast. This was back in 2012 when we began. Cast is a static code analyzer. It works across over 20 technologies now. And the way Cast operates is that over a number of years, they've built up a database of 1,200 rules by technology of what constitutes best practice around performance, security, robustness, and changeability of that application. And it then passes the code and produces a dashboard for you showing certain attributes and quality indicators against those 1,200 rules. But it goes one step further. It will also tell you that where you do have a problem, how do you fix it? And it will provide you the sample code in order to be able to fix it. Because there's no point in just knowing you have a problem if you don't know what the solution is to repair it. It will also give you, and this becomes useful in a moment, and when we look at introducing that into our life cycles, of what is the architectural design of the application. And often when you're maintaining a customer's application that's 20 years old, all the documentation associated with it has left with somebody, with Bob, who resigned 2 years ago, because it was all in his head. It was never actually documented. Cast will generate that entity relationship diagrams for you. It will do the application dependency charts for you as well, all based on its structural analysis that it does automatically. So how do we use it? What is quite interesting is that rather than just do one analysis during our build lifecycle, and this is the example when we're actually writing software. So I apologize, it's not an agile approach. It's slightly more waterfall, requirements, design, build, UAT, and deployment, as you see. What we encourage and what we do is when we're actually building each component, application component, a developer will use their own IDE tool set. They'll be using JUnit, they'll be using many things themselves. We don't standardize on that at all. Each developer has their own particular favorites. Once we do the first combined build, however, we push it through Cast. And Cast will take anywhere from a couple of hours to a couple of days to run through that first build, depending on the number of lines of code. And from that, we actually see what the overall quality of the code is. You can generate an action plan, yada, yada, yada. But for me, what's more interesting is not that. What is interesting is that each Cast analysis that is done populates a database that we're maintaining of the key issues that are found again and again and again. And that is then fed back into the next project that is done and actually used as training to show these are the common violations that have been found in the last 5 years. Don't do them on this project. Let's get a first-time right approach to writing software. And that, by the way, is, some of you know, around CMMI, one of the key aspects you need to implement to have this culture of continuous improvement. In the run world, and by run I mean actually managing applications on behalf of clients, we have a slightly different approach. In pre-sales, when you're bidding for work, you do this thing called due diligence that you're probably aware of, where you're trying to check what is actually the application that you're meant to be managing. You're interviewing client staff to see if what they put in the information they sent to you is actually the truth. Often it is, sometimes it isn't. In due diligence, we use a tool, and again, it is CAST to do this, to understand the complexity of the application. And this is where we go back to understanding how many cows do we have to manage, and how many people do we think we need to manage this application going forward, not just how big is the team on the client side. Assuming you win the deal, you go into transition, and the biggest part of a transition, which means bringing in those applications and staff into Capgemini in this case, is knowledge transfer. Because again, there's very little documentation that's probably accurate about the application after 10 years. And in knowledge transfer, because of the dashboards and architectural designs that are built by CAST, we actually use that to train our own staff in how to manage those applications. And then when you move into the actual run of the AM, we see the same process we saw before. Each time you do an enhancement or set of enhancements, you push it through a quality gate. And CAST will give you the result. You either rebuild if you're not up to the right level, or you move into production. And one of the areas I'd just like to mention here as well is there's a huge focus in the industry in productivity and reducing cost to manage applications. Often in AM, that means trying to reduce the number of tickets or bugs that are being detected. If you have this right, this assessment on the structural quality, which we said before accounts for 90% of the issues we're finding in production, and you take some proactive action to improve quality in that application, you can actually reduce the number of tickets you're getting. What we've found, and it was quite staggering when we looked at the results, is that if you can improve the underlying quality of your application, structural quality, by 5%, we actually got a reduction in the number of tickets by 50%. And for any company, client-side or IT provider, that is an enormous benefit, as you can imagine, in terms of getting some reduction in costs of managing applications. Just very quickly, this kind of deployment, you're not deploying PowerPoint. It's not a tool that you're going to put on the desktop and everybody's going to use it. The laboratory is just in the same way, by the way. You don't do your own blood analysis, or at least not for the moment until Philips come up with a home blood testing service. The shared service is basically our blood analysis laboratory in India and Morocco. We have about 5 of them. Sometimes they're onshore where the data is sensitive or the applications are sensitive, and obviously clients don't want software to be sent to India or Morocco in those cases. But they all work the same way. There's a standard service catalog, you pull off it, and they work for multiple projects. And this is the team that is doing the analysis of the code and producing the reports as standard afterwards. But what have we found? And how are we doing at the moment? Well, we've got about 600 million lines of code that we've assessed, which is quite interesting in the industry, actually, not just for ourselves. CAST themselves, after many years, are only at 750 million lines. So we've got an awful lot of data now from which we can start to draw some conclusions about how is the industry itself improving or not in terms of structural quality of its code. And what have we found? Well, this little graph on the left is what we found. The good news is that over the last 3 years, inherent software quality is improving. Okay? That's the last column. It's called TQI. It's the overall quality, structural quality measured on applications. It's out of 4, by the way. 4 means that you're absolutely perfect, no problems at all. Overall, we're now at 3.1. It's quite an improvement over 2013, in fact, and that was just up until the end of September. What's also interesting in this is that security, which is an absolutely fundamental question today in the software industry, is improving dramatically. There is a huge improvement in how secure applications are being built and maintained across the marketplace. And that's a big step up from where we were a couple of years ago. What is more worrying from my point than even security is performance. It lags behind the other metrics every single year, and the improvements are tiny. And yet, when you look at applications today in terms of the volume of users online internet-based applications. When they are not performant, it is far more critical today than some of the issues that we're finding. And yet the industry is not putting enough emphasis on improving the quality of the software that is being built related to how performant they are at large-scale user bases. When we look across at CAST's results, which was based on about 700 million lines of code, every 2 years they publish a report called the Crash Report, which is a kind of reassuring title from a quality company. This one was 2014's. And again, one of the other big trends that has been there for some time now is the move to Agile. Product companies adopted Agile, decades ago. But clients, on the promise of it being cheaper, better, faster than traditional ways of building software, are biting it and eating it at ever-increasing volumes. What was interesting is in this report, they compared the quality of software, structural quality of software coming out of an Agile project versus the rather more boring and sleepy waterfall lifecycle. And the astonishing news they found was that, in fact, there's absolutely no difference whatsoever in the quality of code that comes from Agile as it comes from waterfall. And in fact, can't really see from this, but the overall total quality is just a little bit over 3 in the industry today when you look at either of those approaches. So whenever you find a Scrum Master or an Agile evangelist that tells you that quality is far better with Agile than waterfall, you have some evidence to say it's not always the case. But what was interesting is that they also looked at the quality from hybrid projects. And in fact, let's be honest, in large-scale software development, there are very few that are pure waterfall or pure Agile today. It's a kind of hybrid mix between the two. And what they found was, in fact, the hybrid model produces better quality than any of the others. And so again, it's a little bit of a cultural issue, I think, for Agilists to adopt waterfall in the same way it is for dinosaurs in the waterfall world to adopt Agile. But I'm afraid that's the lesson learned, and that's the way we should go if we want to improve quality in our software. And the last slide, if we just briefly come back to our cows and cowboys, there's a holy grail being searched for, which is how do we measure productivity? It's a very boring topic, but unfortunately when you're looking at bottom lines and things, it becomes important. How do you measure productivity in software development? And people have been looking for one single KPI or metric. People come up with function points. In the days of old, it was lines of code until they realized that a copy-paste statement could fill your code with 1 million lines that were never used. Function points are absolutely marvelous. It's the only one that's got an industry standard definition to it. But like most standards, it has numerous ways of being interpreted. You ask 10 experts how many function points there are in an application, you'll get 10 different answers. It's not very good when your contract, which is hundreds of millions of euros, is based on that very precise number. So a variance of 5% means many, many millions. However, without understanding that volume of output together with quality of what you're outputting, productivity becomes meaningless. The good news is that, I think it was 2012, again, IFPUG, the Function Point User Group organization, came out with a specification that said, how can I measure these mythical things called function points automatically? Suddenly, all of the experts on function points became very nervous, as you can imagine, because they saw that automated tools would come along and the measurement of function points would become robust and repeatable and all those other good things. And indeed it did. It took 6 months for companies, quality assurance companies, tool vendors rather, to introduce that specification in their tools. CAST have done it already. However many times you run that tool over an application software, you get the same number of function points. Okay? You now have a cast iron way, pardon the pun, of actually being able to measure the number of function points in an application. That can then feed into your productivity calculation and give you, at last, a value for how productive a team is, an individual is in writing code. The only slight problem, and I wish it was a panacea, is that that's only okay for certain technologies and certain types of application. Middleware applications, it still has some way to go, but as you probably know, function points are not that well suited to middleware applications anyway. So there is still a lot of work for consultants to do. There is still life out there for function point counters. We are not yet there at having a single metric for productivity, but unfortunately the appetite for one in the industry is such that it will come. So that was just a brief introduction to this case study around how we've introduced structural quality assurance in our own life cycles. It's an ongoing process, I can tell you. Quality always continues. I hope that's been interesting and useful for you. Thank you.
We have time for 1 or 2 questions, please.
Thank you for the interesting presentation. I was thinking, do you also use this kind of quality assurance measurements in an implementation in real life, for instance? So this is the development, but I'm very interested in how you measure an implementation, for instance, let's say an ERP system in a hospital. Mm-hmm. And can you make the costs of risks visible?
Very good question. I don't think, on the first question, we actually don't have a choice anymore. Because the market demands, by market I mean clients, demand that if you cannot prove that the quality of your implementation is at a certain level, they don't pay you. So it's now a contractual commitment. It comes in with the tools as well, by the way, that if you can't show that you're at a certain level, like 3.3 out of 4 or whatever, you don't get paid anymore. So there is a real motivator from the client now to focus on this and get it right. But it's only at the software level. The overall implementation, the change management and what have you, that cannot be measured today. There isn't a way to do that, I'm sorry to say. It's only at the software level. Yeah, absolutely. And when you're looking at packages as well, by the way, 70% of what you're doing, 80% in packages is organizational change management and configuration. It's not software. So I think packages is still a little problem with quality assurance, if I may say so.
Okay, the answer was long enough, so we have no time for more questions.
Sorry.
Never mind, it was really interesting. Thank you once more. And now, the end of the session. Now we have coffee break.